All right, so in this example, we're looking at tattoos. We have a Pew Research poll that was taken in 2010 that surveyed 830 people, 18 to 29. And so we're going to highlight our numbers as we go. Let's make sure it's yellow. Good. So 830 people ages 18 to 29, they found 166 of them had one or more tattoos. Now, previous studies had shown that 16% of that age group had tattoos. Is this strong evidence that the proportion of people with tattoos has increased? All right. So, what do we know? What information has been given? Well, we have a sample size, don't we? 830. Okay. Are we testing a mean or a proportion? Well, it's pretty clear here, right, in the question. Is this evidence that the proportion of people with tattoos has increased? So obviously, we're testing a proportion. That means we will be using a z-score, right? Okay. Do we have a sample proportion? Yes, we do, right? 166 out of the 830 had tattoos. We don't need a Q hat, but we do we know, do we have a claim made against as far as what the value of the population used to be? Maybe still is, right? Yes. Previous studies had shown 16%, 0.16, had tattoos. So remember, null hypothesis is a statement of no difference. So we're going to start by saying right now, or 2010, right, that the proportion of people with tattoos in that age range has not changed, that it's still 16%. So that is our null. P equal to 0.16. So you've got to make sure that you have that parameter there, not just the equal 16% or not just the 16% or 0.16. It has to be a complete mathematical statement. P equals 0.16. I don't care if you use 16%. Either of those is fine. All right. What about our alternate? Well, what do we expect to be true, or what do we think is true? First off, we're going to write our alternate exactly the same way as the null, except for the sign in the middle. We think things have increased, so that means greater than, right? Okay, I'm going to throw my sketch in here. So our hypothesized proportion, the center of our distribution, 0.16. Now, I don't know what 166 out of 830 is, so let's pull our calculator and say 166 divided by 830 is 0.2. All right, so not a huge change, but that's a pretty large survey. And the larger your samples are, kind of the more you can distinguish between sampling variability and relatively small changes. But yeah, that's a 4%, that's like a 25% increase still, right? So 166 out of 830, we'll just say that's 0.2 because it is. All right. And where are we shading to represent our p-value? We are shading the greater than, let me go back. We change it to yellow. There's a little more contrast there, right? We are shading the greater than side. Okay. We do want to make a habit of checking our conditions, right? So is our sample random? Well, it's a professional research organization. You better believe they're taking a random representative poll. So that is very safe to assume here. All right, but that, even though it doesn't say random, it's a very safe assumption because Pew Research is a professional polling organization. They know what they're doing. All right, do we have at least 5 successes and 5 failures? Well, let's see, we've got 830 times 0.16, because remember, we're going to use P here. If you think you know P, you're going to use it, right? So 830 rather, 830 times 0.16, that gives me 132 0.8, which is bigger than 5. All right. 830 times Q. Remember, Q is 1 minus 0.16. So that's like 0.84. So 830 times 0.84, that's a lot. 697.2, that's bigger. We're good to go. Great. Okay, I'm going to switch colors here because why not? So we need to calculate our test statistic. So remember, we're doing a z-score. So we know z is p hat minus p. We're doing a z-score for proportions. P hat minus p over square root pq over n. So remember, if you think you know p, use it in the standard deviation, or the standard error rather. Standard deviation here, sorry. All right, so what do we got? We've got 0.2 minus 0.16 over square root 0.16 times 0.84, right? That's our Q, over 830. And we're going to go throw that into GeoGebra to calculate this. All right, so we got 0.2 minus 0.16 over square root 0.16 times 0.84 over 830. And so again, we're getting a pretty big z-score. That's not always going to happen, but the examples I've picked so far, it's happened. All right, so we've got 3.143. All right. Equals 3.143. So this is our test statistic, our z-score. Now we need to find our p-value. And so we're going to go back to GeoGebra. We were just there. We're going to go back. We are going to go to the probability calculator. We have a greater than for our alternate hypothesis, so we're going to make sure we have that right-tailed selected. And we're going to put in our z-score 3.143. And so again, our p-value is pretty small, 0.0008. Usually 4 decimal places is going to be enough. I'm going to go with 0.00084, rounded. Okay. So the probability p hat greater than or equal to 0.0008. What do we say, 4? I've forgotten. Yep, 84. Okay, forgotten already. There is our p-value. All right, and so again, what's our conclusion? Well, that's a super, super small probability, right? If the proportion of people with tattoos is still 16%, the probability of getting the sample that we did, or anything further higher, is 0.0008, right? It's really, really, really small. So that says really, really, really unlikely, right? Our sample is very unlikely if p is actually still equal to 0.16. And I'm making some room here. So, right, so therefore we will reject the null because our p-value is very small. What does that mean? Well, and again, this is where you can take that question from the problem and restate it as an answer, right? Is this strong evidence? Yes. Yes, there is strong evidence that the proportion of people, specifically 18 to 29, but I'm just going to say people with tattoos, has increased. And we can't say by how much. You need a confidence interval for that. But we can say very, very, very strong evidence that it has in fact increased, and it is something more than 16% of the population. There we go. Done the whole hypothesis test.